welcome to your favorite intermediate algebra class. Good to see you guys today. We're going to talk about probability of compound events. We're going to find some probabilities of unions and intersections. And we're going to use some complements to find some probabilities. Okay, so if you look in here at these um, diagrams here, these images, and that paragraph below, when you consider all the outcomes for either of two events, A and B, you form the union of A and B. Okay, can you see the union here on the left-hand side in blue? Okay, that's the union. So all of A and all of B there. Now, if you look at the what's called the intersection, right, the middle diagram here, that's showing you the intersection of A and B. So the outcomes that both A and B share, right? Both A and B share those. That's your intersection. And finally, the diagram on the right, that's showing you the A and B. There is no intersection. They don't share any outcomes. Okay, that's called a mutually exclusive events there. Okay, event A and event B are mutually exclusive. They have no intersection there. Okay, so if you're finding the probability of A or B down here below, okay, probability of mutually exclusive events. Okay, so if they fit the diagram on the right, okay, they have no intersection, then your formula for probability of event A or event B happening is just the probability of A plus the probability of B. Okay, and we're going to do some examples with this. Now, if they look like the middle diagram there, so they are compound events, okay, so you have an intersection there. You don't want to double count the intersection, those outcomes in the intersection there. Okay, so you have to, the probability of A or B is probability A plus probability of B, but then you got to subtract out the probability of A and B. Okay, so again, so there's no double count there. So let's look at some examples here. Maybe we can kind of clean this up a little bit. You roll a number cube. You roll a number cube. What's the probability of rolling a 3 or a 4? Okay, so let's let event A be event A is rolling a 3, and let's let event B be rolling a 4. Okay, they don't share. These are mutually exclusive here. Okay, so the probability of A or B is simply the probability of A plus the probability of B. Okay, so probability of rolling a 3 or a 4 is simply the probability of rolling a 3 plus the probability of rolling a 4. Okay, which is if you roll a 3 on a number cube, right, you have a 1 in 6 chance. There's one number there, and then you have a 1 in 6 chance of rolling a 4. Okay, so this ends up being 2 in 6 or 1 in 3. So probability of rolling a 3 or a 4 is 1 in 3. And this is a pretty intuitive one because you're thinking to yourself, well, out of 6 numbers, I got 2 of them that are kind of winners, if you will, a 3 or a 4, right? So 2 out of the 6. 2 out of the 6, which is 1 in 3 chance. Okay. But again, you got to be careful and make sure that it's mutually exclusive to run this formula, probability of A plus probability of B. It's got to be mutually exclusive. Second one, you roll a number cube. What's the probability of rolling a 2 or an odd number? So let's let event A is probability of event A, sorry, it's probability of rolling a 2. And let's let event B be the probability of an odd number. Okay, so you got probability of rolling a 2, and then you got your odd numbers 1, 3, 5. Doesn't look like there's any crossover there, is there? So again, these are mutually exclusive events. So since it's mutually exclusive, probability of A or B, probability of A plus probability of B according to the mutually exclusive formula. So probability of rolling a 3, rolling a 2, oh, I'm sorry, probability of rolling a 2, fix that here, or an odd number, probability of rolling a 2, plus probability of rolling an odd number. Well, probability of rolling a 2, I got 1 out of 6, right? 2 is one of the 6 numbers. Odd, now I got 3 out of 6 numbers here, right? So this is 4 out of 6, or I got a 2 in 3 chance that I roll a 2 or an odd number, okay? So these are examples of mutually exclusive events. All right, let's do a compound event now. Okay, you roll a number cube. What's the probability of rolling a number less than 4 or an even number? Okay, so let's let event A be a number less than 4. Event a number less than 4. So I'm like thinking to myself, oh, okay, well, I got 1, 2, or 3, right? In event A. And then event B, an even number. Like, wait a minute, I got 2, 4, and 6. It looks like these they share that too, don't they? This is event B. Can you see how this is a compound event? This is not mutually exclusive. They both share the 2 there, okay? So the probability of A or B is probability of A plus probability of B minus the probability of A and B. Okay, so we got probability of A, event A. So any number less than 4. So I have the numbers 1, 2, or 3. So 3 out of my 6 numbers on a number cube. That's my probability of rolling a number less than 4. Now the probability of rolling an even number also happens to be 3 out of 6, right? 2, 4, or 6. But you notice I've double counted the 2. So I gotta pull out the probability minus the probability that you are a number less than 4 and an even number. In other words, the probability that you roll a 2. Okay? You know what? Maybe I should have written this down right here. Sorry. Add an extra line here. This is the probability that you have a number less than 4. This is the probability that you are even. And this is the probability that you're less than 4 and even. In other words, this is the probability that you get 2, right? Probability that you roll a 2. So we got 3 out of 6. We got 3 out of 6, but we got to subtract the 1 in 6 chance of rolling a 2, right? You don't want to, again, you don't want to double count this thing. So we got 3 plus 3, 6 minus 1. 5 out of 6 is our probability that we roll a number less than 4 or an even number. Okay, and you think about that and you're like, oh yeah, I guess 5 of the 6 numbers are going to be less than 4 or even. The only one that's left out is the actual number 5. Okay, so it makes sense, doesn't it? So just these, when you have these compound events, the whole thing is don't double count when you have the intersection there. So thus the formula there, subtract out probability of A and B. All right, next example. A card is randomly selected from a standard deck of 52 cards. What's the probability that the card is a heart or a face card? Okay, so let's let event A be, event A is your heart, okay, and event B is a face card. Face card. Okay, so you got, and do they have an intersection? Well, you say, well, yeah, sure. There's also, you know, there's those Jack, Queen, King that are hearts. Okay, so you got all these hearts. 2. Again, these are all hearts. 2, Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King, right? And these are all hearts. Jack of hearts. These are all hearts, right? Hearts. Not a very good picture, but anyways, I got all these face cards over here. Jack, Queen, King. Jack, Queen, King of, let's do our spades next. Jack, Queen, King of our diamonds. Jack, Queen, King of our, who am I missing here? Our clubs. Ugh. Anyways, see how there's those intersection of Jack, Queen, King of hearts there? Okay, so what's the probability that the card is a heart or a face card? Yeah, so probably this is a compound event. So I got to use this formula, probability of A plus probability of B minus probability of A and B. Okay. This is probability as a heart or face card. Probability as a heart plus probability as a face card minus probability as a heart and a face card. Okay. Alright, so we go through this probability as a heart. I say, well, how many hearts are there? There's 13 of those things out of this standard 52 card deck, right? How many face cards do I have? I say, well, I got 3 face cards, 1 in each suit, so it looks like we got 12 of these face cards, but I'm double counting, so I got to subtract out heart and face cards, right? So my intersection, I got 3 of these things out of 52. Okay, so 13 plus 12 minus 3 looks like, what's that, 25 minus 3, 22 out of 52, or 11 out of 26. That's the probability that you draw a heart or a face card. Okay, compound event there. Okay, in a poll of 50 students, 19 were student council members, and 33 played a winter sport. Okay, 48 of the 50 students, 48 of the 50 were student council members or played a winter sport. What's the probability a student is a student council member and played a winter sport? And played a winter sport. Okay. Well, let's let event A be that you are being a student council member. Okay. B is that you played a winter sport. All right, so let's write down what we know here. Well, probability that you're a student council member. It looks like in 50 students, 19 of them, 19 out of the 50 were student council members, right? And then probability that you played a winter sport, 33 out of the 50, right? Now there's going to be some intersection here, because if you think about 33 plus 19, that's 52 people, right? So some people were student council members and they played a winter sport, okay? And it looks like here, and they actually say, hey, 48 of the 50 were student council members or played a winter sport. So it's one or the other, okay? They were one or the other. 48 of the 50 did one or the other, okay? Student council member or they played a winter sport was 48 out of 50, okay? So it's kind of like we already have our answer there, probability of A or B. And again, this is, there's crossover here between the two. This is a compound event, right? Where you have your student council members on the left playing winter sport on the right, okay? So now we go to our equation here, and we're going to figure out finally what this thing is asking. What's the probability a student is a student council member and played a winter sport? Okay, so say, well, since these are compound events, I have this formula. And we have the A or the B, 48 out of 50. We have student council, 19 out of 50. We have playing the winter sport, 33 out of 50. So we're just trying to figure out the probability that they are a student council member and that they played a winter sport. That last variable there. Okay, so 48 out of 50 equals 19 out of 50 plus 33 out of 50, 52 out of 50 minus probability of A and B. And again, we're just solving for probability of A and B. So let's subtract 52 out of 50 here. Looks like we got 48 minus 52, negative 4 over 50 is negative probability of A and B. Let's get rid of the negatives there. So 4 out of 50 is the probability that you are a student council member and that you played a winter sport. 4 out of the 50 students. Okay, or actually, you know what, I should probably reduce that. 2 out of 25. It should be, what is that, 0.08? Same thing, all right? So we have an 8% chance there. All right, let's talk about complements. Complements. So complement is like the opposite. Okay, and you read that A prime, by the way, that A apostrophe there. So A prime, the complement of A, it consists of all the outcomes that are not in A. Okay, so if you think of all the outcomes that are not in A, you know, so like let's say you have I don't know, the probability of something is 0.6. Well, the probability of that not happening is 100, or 1 minus 0.6 of 0.4. Okay, so best probably explained here with an example here. When two number cubes are tossed, there are 36 possible outcomes. Find the probability that the sum is not 5. Okay, probability that the sum is not 5. Well, first of all, let's write out these outcomes. Two number cubes are tossed. So you could roll a 1 and then maybe another 1. You could roll a 1 and 2, 1, 3, 1, 4, a 1 and then a 5, a 1 and then a 6, right? Or maybe you roll a 2 and then a 1, a 2, 2, 2 and then a 3, a 2 and then a 4, 2, 5, 2, 6. Or maybe you roll a 3 and then a 1. So I'm writing all possible outcomes here. Maybe you roll a 5 and then a 1, and then you roll a 5 and then a 2, or a 5 and then a 3. So here's all your options when you roll 2 dice. Okay, two number cubes are tossed. 36. You see all 36 outcomes here? Find the probability that the sum is not 5. So the probability of A prime is 1 minus the probability of A. Okay, so for instance, probability of the sum is not 5 is the exact same thing as 1 minus the probability that the sum is 5. Okay? So let's think about that. All right, well, what is the probability that the sum is 5? Well, how many of these things add up to 5? Okay, I'm like, well, there's one. There's one that adds up to 5. There's one that adds up to 5. There's one that adds up to 5. So it looks like we have 4 of these out of these 36. Okay, so change that 1 to 36 over 36 minus 4 over 36. Looks like we have 32 out of 36 is our probability that the sum is not 5. So what's that, 16 over 18, or 8 over 9, all right? Probability that the sum is not 5 is 8 over 9, okay? So that's a complement. So it's just the opposite of. Okay, the opposite. So the probability of A prime is 1 minus the probability of A. Okay. So, and if you're looking at that equation, if you add probability of A to both sides, that kind of makes sense here because you have probability of A prime, the opposite of A. So the outcomes, right? The probability of A prime plus the probability of A equals 1, right? According to this formula. So like for this problem, you know, A prime, all of them, how many of them were not summing to 5? Well, there was 32 of those out of the 36 outcomes that summed up to not being 5, right? And then the probability of A, you know, you had 4 of these things that actually did sum up to 5. And you notice that that's 36 over 36, which is 1. Okay, so the complement of the event. Thanks you guys for listening. We'll see you guys soon in class. Bring your questions.